This section involves integrals and recognizing patterns, where our answers turn into the inverse trig functions. Good news is there is only three patterns that we have to really know. I will tell you the first two patterns are the ones that pop up the most often, that we use the most frequently. This just pops up occasionally, so we just got to work with this so we're thorough with our notes right there. But these first two are the ones that we'll use the most often right there, okay? Now, these are also on your blue sheet review right here. I got those three things right there. That's what we're talking about right there. Now, when we recognize these patterns, I would get those three things jotted in the cloud there at the top of our notes. And then when we're looking at these patterns here, the A is the number part that's being squared. The U is the variable part that's being squared. So when we see things like 1 over, or even like a 4 over, or just a number over the square root of like 9 minus 25x squared, we have a number part squared minus a variable part squared. That's going to be the arc sine pattern. When we see no square roots and we see like 25x squared plus 9, or 49x squared, plus 36, or a variable part squared plus a number part being squared, that's going to be like this arctangent pattern right there. So when we recognize the patterns, a lot of these involve UDUs and recognizing the patterns. And then what we get when we get our answers, the answers all have like arc sine, arctangent, arcsecant pattern. They all have u over a, u over a, u over a in them. And then these two here have the 1 over a extra piece in front. All right. And this one doesn't have the 1 over a in front right there. All right, so let's just kind of go through some of the examples. There's some problems in the homework are going to be pretty straightforward. Usually this is a very rough assignment for students there. There's just a lot of stuff in there. There's a lot of things in there that we kind of do to kind of turn it into the pattern there. So sometimes we have a bunch of questions. There's a couple weird things that happen in the homework there. It's typically a rough assignment for students there, but we're just going to kind of get you so many notes here, and then we'll go through some more questions as we're going through the homework and stuff there. All right, now, all right. So when we recognize the patterns there, so these first two examples are some pretty basic, pretty typical examples for us to start off here. UDUs are not going to work on those. XDX is not going to work on those. So what we got going on is I recognize a number part squared minus a variable part squared. That's my arc sine pattern, the a squared minus the u squared. So once I recognize this is an arc sine pattern, I'll typically just jot that down for myself. Hey, this is an arc sine pattern. And I'll write down my a is that number part that's being squared. My u is the variable part that's being squared, which is a 2x, because if you take a 2x and you square it, you get that 4x squared right there. All right, now, if your u is equal to something, then you're going to do like a u du. So then your du, the derivative of that is just going to be a 2. And then so this 3 is part of your problem. So we're going to pull that out. You're going to balance that 2 like you normally do with the u du, with the 1/2. And then what you have here is like 1 over the square root of like 1 squared minus the u squared, because again, that u is the 2x. So if I plug it in and I square it, I get that 4x squared, right? So typically if I have stuff to balance, I'll rewrite it like this in terms of the u, the du. And then this is our pattern here, where once you get it matching that pattern, now we can go straight to the answer. So when I integrate this according to our pattern here, this is going to be the arc sine of u over a. And so it's going to be u over our a is equal to 1. We're going to get our plus c, and then that 3/2 is going to carry down. And then all we have to do now is plug our x's back in. And so it's just going to be 2x over the 1. So it's just going to be 2x, and then you have your plus c, and then you're going to be done. So I tend to like these integrals. I tend to like these problems there because I kind of like puzzles and I like seeing the patterns and stuff there. Sometimes in the homework, we are going to have to get a little bit of creative with some of these problems there, but these should hopefully be pretty straightforward, the first couple that we're doing. All right, so when I look at this next example, I'm seeing no square roots. I'm seeing a squared plus u squared or u squared plus a squared. Remember, addition is commutative, so it doesn't matter the order there. And it doesn't even have to be a perfect square. That could have been a 19. And so your a is the square root of 19, right? And so, but when I see, I can't do a u du right there. Now, if I put an x on the top, I could do a simple u du, right? Let the u equal the denominator, it's going to work out. But I can't do a u du or anything on here, but I see a pattern of a number part being squared plus a variable part being squared. So that is this arctangent pattern. So I'll jot down for myself, hey, this is the arctangent pattern. And I always write down what my a and my u are equal to. So my a is this number part that's being squared. So that's going to be 3 because 3 squared gives us 9. And the u is your variable part being squared, which is a 5x, because when you square 5x, you get that 25x squared. And then if your u is equal to something, you are going to do a u du. All right, so take the derivative of that, which is just going to be a 5. And then, so this 4 is part of your original problem. So you just pull that out. And then that 5 is an extra with the du. So you balance that 5 with the reciprocal, the 1 over 5. So you got 4/5 out there. And then I'm going to rewrite this thing. So the 4 is already handled. So I'm going to go 1 over. This is like a 3 squared plus the u squared, tag on the du. Now you can just leave that as 9 plus u squared if you want there, but I really like to just match that pattern as closely as possible. So I have a number part being squared plus that variable part being squared. Again, if you plug in that 5x right there and square it, you get that 25x squared. And now this is matching this pattern right here. So then when it's time to integrate that, that's when you integrate, go straight to the answer. So that this time, when you have an arctangent, it's going to be a 1 over a in front. So that's going to be a 1 over 3 arctangent of the u over a. So that's going to be u over our a value of 3. And then this 4/5 will carry down. So the arc sine pattern doesn't have that 1 over a in front, but we got to know the arctangent pattern and that arcsecant pattern has that 1 over a in front. It seems like some of the problems on the homework there, that a is equal to 1 too much. So if you forget that, then you won't even recognize that. But just be careful with that. If your a is equal to something, you got to put that 1 over a in front. And then our final answer, we're going to get a 4 over 15 arctangent, and then plug your x's back in. So this will give us 5x over 3, tag on the plus c, and then we're done. Now, if I wanted to, if I took the derivatives of those two things, using what we learned in the last section, the inverse trig function derivatives, using these properties right here from our blue sheet, you would get these original integrals right there, those integrands, what we got on the inside right there. Okay, and then what we're really going to have to use in this section is our brains, because sometimes the problems don't quite look like the patterns right away, and we just kind of have to be a little bit creative sometimes and kind of working some other things into the problem, which we'll show you in the homework there, and just do the best you can with those and try to figure everything out. Now, I just want to stress, this problem I already have worked out for you. Just because you see a squared minus u squared doesn't mean it's going to be that arc sine pattern right there, okay? Notice that you have an x up there. And so if you let your u equal the inside of that square root, do your du, you get that x to match up with the squiggles, balance the -2 with the -1/2, pull the 3 out, and then you got your normal u du. And that's just an easy integral it could have given you last chapter, okay? Now, I'm not saying that you won't ever have x's on the top when you have these patterns. Now, these patterns are with the numbers on the top, but if I put an x on the top and I made that an x to the 4th inside that square root, let's just kind of think about that. Like if I'm not going to do this whole thing, but if I made that a 4, I could leave that x up there, because then look, this would be like a 1 minus x squared squared, right? Where I'm seeing the a squared minus u squared pattern, and then my a would be 1, my u would be that x squared, because when I do the du, the derivative of that would give me that 2x, right? And then, so then I would get that x dx to match up. So that 3 would pull out, I'll still balance that 2. And then you have the 1 over the square root of like 1 squared minus that u squared. And then see, that particular example would be an arc sine pattern there. So there's like little things like that that'll pop up that you just got to use your brain. So I'm just going to try to give you a little bit of everything in the notes here, and then we'll learn quite a bit more when we're doing the homework and going through that struggle a little bit there. All right. Now, whenever you see an arc function inside your integral, remember what we talked about before. If you have an ln inside that integral, you have to let your u equal the ln part. Same thing here. This is an easy problem, because if you have an arc function inside the integral, you must let the u equal the arc function. So just like before, if I have the integral of ln of x, what we had to do before, I had to make that work out to where it was a u du. So let your u equal the ln part, the derivative of that gives you the 1 over x. What we'll learn in a future chapter is how to do it when it's not a u du. But we can't ever go straight to the answer right there. Even when we do this indirect approach, there's going to be something called integration by parts. We're going to have to let the u equal the ln part. So like right now, when you see an arc function inside the integral, that means I have to make it work out with a simple u du, and you have to let your u equal that arc function right there. If you don't let your u equal that, I can't give you any points. You get 0 points on that problem whatsoever. So I have to work this work out with a UDU. Now, if it's not a UDU, if I just give you something like this is going to be like along this line here, where that's going to be a future chapter. If it's not a UDU, we can do it, but we're not going to be able to go straight to the answer, and our U must equal that even when we learn that new technique in the future there. So here's the good news. When I see an arc function, boom, I know right away the derivative U has to equal that arc cosine, and then we're going to take the derivative. Now, you do have to know those properties from your blue sheet from the last section there. If I do the derivative arc sine, I do the derivative of that thing over the square root of 1 minus that thing squared. And if I have arc cosine, it's the same thing, but you just stick the negative in front. So I do the derivative of that x, which is 1, over the square root of 1 minus that x squared. That's how you do the derivative of arc sine of x, but the arc cosine of x, you just get the negative right there. And then notice what we got going on is I got a 1 over that square root, and right here I have a 1 over that square root. So that's like the squiggles part of the problem. That's matching up, and that's what has to happen in this chapter because we don't know integration by parts yet. And so then we'll balance that negative with the negative, and then your U is equal to that piece right there. So remember, the squiggle stuff is handled, your U is equal to that arc function. And now look how simple this integral is right here. Now, so when you integrate the U, you're going to get U squared over 2. You got the negative carried down. Now, you could plug the x's back in. I'm not sure if anyone really wants to plug an arc trig function back into the problem. So I'm going to stop right here, and I'm going to plug in numbers. I just can't plug in those original numbers because those numbers are x's. But what I can do is switch my x's to u's using this initial substitution step. So if I plug in that 1 over radical 2, this is going back to the inverse trig review that we gave you in the last section. This is the arc cosine. You're more familiar with that as the square root of 2 over 2. That's the angle whose cosine is square root of 2 over 2. And hopefully you just know that's going to be pi over 4. And if I plug in 0 for the x, that's when I do arc cosine of 0. That's the angle whose cosine is equal to 0. That's the angle whose x value is equal to 0. So that's at a pi over 2 right there. And then so usually this negative 1/2, I'll just carry it out. I got a negative 1/2 right there. And then I'm just going to plug into the u squared. So I'll plug in the top number. So that'd be like pi squared over 16. And I'll plug in the bottom number. So that'd be like pi squared over 4. And then that's really like negative pi squared over 32. Actually, no, I'm just going to go ahead. I could probably get one single fraction right there because they're both pi squared. So let's just go ahead and do that real quick. I'll times this by 4 times this by 4. So this would be 1 minus 4 pi squared. That would be negative 3 pi squared over 16. And when you times that by the negative 1/2, that's going to give us a positive 3 pi squared over 32. Okay, so we got the normal problems where you got to recognize the patterns. There's going to be some problems you're going to have to rewrite. I'm not going to show you everything there. We got to get that experience, practice a bunch first, and then we could talk about some extensions of this thing. And then you got to just try to do the UDU. You know what to do with, you got the arc functions in there. And then I just need you to be as persistent as you possibly can through this homework assignment. So if you get stuck, keep on going because there's some problems at the end that are very similar looking to these guys right here, which you can do those. So you just gotta leave some space, do as much as you possibly can and keep being persistent with that and going through the problems. All right, these problems right here. Remember when you integrate 1 over something, sometimes I have people make the mistake across the nation that they say that's the ln of that trinomial. Remember, it's not an ln unless it's 1 over a single letter. I don't have 1 over a single letter there. You cannot say that's the ln of anything, okay? These don't look like these patterns, but it's in this particular section. So you're wondering what's the deal, right? Or these are just brand new things that we can't do yet. Both of these problems right there, I tell you, we're gonna do some algebra. We're gonna do an algebra technique that you did ever since Algebra 1. You did it some more in Algebra 2. I know you did it for sure in pre-cal. This is where, when it looks like these, what we're going to utilize here is completing the square. These are both problems involving completing the square. And so here's how that's going to work. Let me review that. When you complete the square, what you work with is the x squared term and the x term. This plus 13, sometimes you have a number there, sometimes you won't. You just kind of leave that chilling out on the outside right there. So what you do is you look at that middle number, which is a 4. You do half of the middle number and you square it. So half of 4 is 2. When you square it, that's going to give you a 4. Now, if you put a plus 4 right there, you change the problem. So to compensate for that, you're going to do a minus 4 right there. So you just added 4, subtracted 4. And then when you condense it, you're going to have a parentheses squared. 13 minus 4 is a 9. That's an easy part there. And then you got x is this sign, whatever sign this is right here, that would just carry down. This number right here is always half of that middle number. So half of that 4 is going to be a 2. If you multiply all that stuff out, you do get that original trinomial. Notice that's all in the denominator. So now we're looking at this for our integral. All right, and then check that out. Some of you are seeing right there, it's kind of a pleasant thing right there. Like you just went over a trinomial, you couldn't integrate that, but you did that completing the square root algebra step where you had you do those things last year for a reason. And now you have a variable part squared plus a number part squared. That is your arctangent pattern right there. So you just did that algebra to turn it into that. And so when I see a number part squared plus a variable part squared, or a variable part squared plus a number part squared, it doesn't matter the order there, that's our arctangent pattern. And I'm going to write down what my a is equal to. My a is my number part that's being squared. The u is the variable part that's being squared, which is just that x plus 2. And here the du is just equal to 1. Now, typically, if my du is equal to a number, I will rewrite the integral using u's like I did on these two examples, and I'll be careful with my balancing. But if my du is equal to just 1, and there is no balancing, I'll typically will go straight to the answer there. So when you have the integral of 1 over u squared plus a squared, that's going to be 1 over a arctangent of u over a. So I'm going to go straight to that answer there. So I'm going to go 1 over 3 arctangent of u over a. So that's going to be the x plus 2 over the 3. And then we got the plus c, and then we're done. If I have numbers attached to there, I got to plug that in there, and I got to know my pre-cal stuff, that cloud stuff that I showed you, how to get the arctangent of -1, arctangent of you know, just all those normal things that we learned in pre-cal last year. All right, that I reviewed for you in the last video. All right, so the last one here, last one in our notes, it just looks a little bit different, but this is also completing the square problem. So I was just worried if I didn't show you an extra example there, like I think you'll recognize, oh yeah, I know to do completing the square on that now, but this one also you're gonna do a completing the square. And then sometimes they'll put extra stuff up there, and sometimes it'll be a UDU, sometimes it'll be a normal problem, sometimes we might need to get a little creative, matching up these properties somehow. But let's practice as much as possible, and then we keep get that experience in, and then extending all this stuff. All right, so when I look right here, when you complete the square, remember you only work with the x squared and the x term. If you have any numbers out in front, we're typically gonna just factor that negative out. And so that'll give us a negative, or an x squared minus 4x. If I had any extra numbers there, I would just not worry about that. I would just leave those on the outside, but I don't have any extra numbers right there. And then, so now once you get rid of that number in front of your x squared, then you're gonna do that thing where you do half of the middle number and square. So half of 4 is 2. When you square it, you get 4. So you put a plus 4 right there. Now I know the common mistake is when you put a plus 4 there, you're gonna put a minus 4 right there to compensate for that, but you gotta be careful because you have a minus in front of that parenthesis. So really what you did a negative 4. So since you did a minus 4, to compensate for that, you gotta put a plus 4. So when it's all said and done, you did a minus 4 plus 4, then you're good. Over here, I didn't do that because I didn't have a negative in front. So it's plus 4, I had to do the opposite of minus 4. So to compensate for that and not change that problem. And then when you condense it, the negative is out in front, you're gonna have an x minus 2 squared plus the 4. All right, so then I'm gonna have the integral. I got 2 over, and I got the square root. And I like to rewrite that number part first. I'm gonna go 4 minus that x minus 2 squared, like that. And as you're looking at your patterns at the top of your page there for your notes or on your blue sheet, I see a square root of a number part squared minus a variable part squared. This is my arc sine pattern. So I'm gonna jot that down for myself that, hey, I have an arc sine here. And then the a is the number part being squared. The u is the variable part being squared, which is simply that x minus 2. And when I do a u du, my u is equal to something, I do the du, that's just gonna be a 1. And so if I don't have anything to balance, I'm just gonna go straight to the answer. So since this 2 is part of the original problem, it's like that just pulls out in front. I'm just gonna carry that down. And then when you integrate the 1 over square root of a squared minus u squared, there is no 1 over a in front. You're just gonna go straight to arc sine of u over a. So we're gonna have arc sine of the variable part of the u part over the a, which is 2. and then we tag on the plus C, and then we're done. So there will be a lot of straightforward things in there. There's going to be several tricky things in there. Like I said, be persistent, do as much as you possibly can on your own. There's a couple other things I want to show you, but I just can't show you right now. I need you to get some experience with this stuff first, and then we could talk about a few other things, what happens in the homework there. But you got all the tools necessary to be successful with this and do pretty well with this assignment.